Hey Prob-Stats students, Mr. Mitchell here. We're going to take a look at the least squares regression equation today, finding it by hand. This is something that will be optional for our course. For this year we will use mostly the calculator just because of time restrictions and COVID and time restrictions on class time. So we've already taken a look at how to find the least squares regression equation with the calculator. Again, here's your data. You're looking at root depth of a watermelon plant versus the mean weight of the watermelon that you're getting off of that plant. So we're trying to see if there is a relationship between those two, an association. So you would plot your data points. Now we talked about finding the least squares regression is based on the area of the squares created by these data points, minimizing the area. So the area above the line is equal to the area below the line. So that's where that line is figured out to be drawn. Here's some formulas that we're going to need. Least squares regression equation is y hat equals a plus bx, where b is the slope, a is the y-intercept, and some other things that we need to find. So the first thing we need to do, we need to find SSXY. So here's our formula to do that. You might say, oh my goodness, what does all this mean? Remember, this is the sum of xy, this is the sum of x, the sum of y. So it's just some notational things. The calculator does most of it for us. We could have to do all of that by hand. So if you haven't downloaded your calculator and you had to do this by hand, then it's going to take a while. Okay, so when I go to the calculator, I type in my data, and I already did that ahead of time for time's sake. So I type in my x's into L5, my y's are in L6, and I typed in all my data. There's 15 data points. So I type those all in. So then I go to stat, I go to calc, I go to 2var stat. Since we have two variables, we've been doing one variable statistics before, but now we're going to do two variable statistics because we're dealing with two variables. So you select that, and then my x list is L5, my y list is L6. Don't worry about the frequency list, and then you're going to calculate it. So there's a lot of information here, and looking at my formula sheet tells me what I need to find out of all this stuff. So when I look back here at my formula sheet, to find SSXY, I need the sum of XY, the sum of X, the sum of Y, and N. So I got to go record those things. Also, I need SSX, so that's the sum of the x's, the x squareds, and then I need the sum of the x's and square that. And then I also, to find the y-intercept, I need y bar and x bar. So I've recorded all those things that I need here already. So here's x bar, here's the sum of x, here's the sum of x squareds, there's n, and we already knew n was 15 data points, but it also tells us that again. Here's y bar, that's the mean of y. Here's the sum of the y's. Here's the sum of xy. And then here's the sum of y squared. We don't necessarily need that right now, but that is a number that we would need for future things. So I just get in the habit of recording that. So we know all these things, our calculator gave them to us, but we need to record them. Because I'm going to look at my formulas again, I'm going to keep referring back to it. I need to find this and divide them to get the slope. So I need to get the slope of my equation, and then I also need to find the y-intercept. So let's take a look. I've kind of already calculated these ahead of time. So the sum of xy, here's your formula. Again, if you were doing this by hand, the formulas would be in front of you. You're not memorizing them, you just have to use them. So the sum of xy is this number. The sum of x is this number, 277. The sum of y is 192. And then n is 15. So this, you type it in the calculator, and you get this number. So SSXY is 336.4. Then you need to find SSX. Well, again, that's a formula on the formula sheet. Boom, there it is. So I need to find the sum of x squareds. Well, I found that number already. And the sum of x is the same as it was up here, only I have to square it. These two are not the same. Look, this is the sum of x squared, so this is the sum of x squared. Not the same thing. So then I type in all these numbers into the calculator and I get this. That's SSX. Then I need to find my slope. My slope formula is SSXY, which I found up here, divided by SSX. So you divide those two and you get this. This is your slope of your least squares regression equation. It is the steepness of the line. Okay? Then we need to find our y-intercept, which A stands for the y-intercept. So that formula is y bar, the mean of y, minus the slope times the mean of x. So again, I already found all these numbers. I just found my slope. So I plug this number in, and this number in, and I get a y-intercept of 2.06. And then the last thing you do is write your y-intercept and your slope in your equation. So here's my y-intercept, here's my slope, there's the least squares regression line, and that's matches what I would find in the calculator. Just to recall how I do it in the calculator, once you've typed in your data, you go stat, you go calc, you're going to go number 8, lin reg. Make sure your x list and y list are the correct ones, so L5, L6. Calculate. There's my slope. My y-intercept. It's a little bit off, but again, if I'm doing it by hand, I've probably rounded something along the way, so close enough. If you have any questions, let me know.